Good morning to all the respected professors, my fellow classmates, and everybody present here. My name is Harshit Ahir, the student of BTech 8th semester Aeronautical Engineering at University Department RTU, Kota. Today, I am here to present topic of my seminar presentation on the Decoy System under the guidance of Dr. Pankaj Sharma sir. So let's start with the first slide. Introduction. With the precision guided weapons equipped in modern combat operations, a serious threat is posed to the safety of aircraft. To protect the aircraft from missiles, to improve or to increase the survivability of aircraft on the battlefield, decoy system came into being. Active decoys are the principal method of self-defense for military aircraft. Now, missile target seeking techniques. The first one is by infrared tracking, which is the heat-seeking missiles are designed to follow heat sources such as the jet exhaust of an aircraft. And the second one is by radar tracking. It is also the form of an anti-aircraft missiles which use radar to locate their targets. Now, the types of decoys. So, there are three types of decoys which are used, and those are the first one is shaft decoys, the second one is the player decoy, and the third one is the towed decoy. Now, we come on the shaft decoys. Shaft is an electronic defensive countermeasure designed to reflect radar waves and thus obscure aircraft from radar tracking sources. These are in the form of packets, and these packets are ejected from an aircraft in cartridge or projectiles that contains millions of individual fibers. These fibers are made as small and light as possible so that it will remain in the air long enough to confuse enemy radar. The range in length of the shaft fibers is from about zero point 0.8 to 7.5 centimeter. Now composition of the shafts. It was first used in December 1943 by US bombers. At that time, the shafts are composed of solid pieces of aluminium, but now it is also composed of very thin glass monofilaments coated with an even thinner layer of metallic aluminium that is composed of aluminum coated glass fiber. The fibers are of 60% silicate glass and 40% aluminum and contains planes of some other metals like iron, copper, etc. In addition, the fibers are coated with which acts as a lubricant to prevent clumping during deployment. The shaft fibers are equal to the thickness of human hair. Now, ejection of shafts. So, shaft is ejected from aircraft pyrotechnically. Pyrotechnic ejection uses hot gases generated by an explosive impulse charge. Upon release from an aircraft, shaft forms a cloud which is approximately of 30 meters in diameter in less than 1 second. Shaft reflects radar signals and confuse the missiles, and as results, the missile will end up hitting one of those little targets, and aircraft gets escaped safely. Now, shaft rockets developed by DRDO. So, Defense Laboratory Jodhpur, which is a DRDO laboratory, has indigenously developed variants of this technology that are short-range shaft rocket, medium-range shaft rocket, and long-range shaft rocket. This project is collaborated with Pune-based High Energy Materials Research Laboratory. DRDO has also developed advanced shaft cartridge for the IAF, having major advantages over the shaft technology available worldwide in terms of its better efficiency against higher frequency radar threats in modern warfare. The shaft technology to protect Indian Navy vessels against missile attacks was developed last April. So now we come on the flares. A decoy flare is an aerial infrared countermeasure to counter an infrared homing, that is heat-seeking surface to air or air-to-air missile. These are high temperature heat sources, and when they ignite it or burn, the burn temperature is hotter than the exhaust of an aircraft. Now we come on the composition of the flares. Flares are wrapped with an aluminum filament reinforced tape with fitted into an aluminum case. Flares are commonly composed of magnesium in the form of pellets or another hot burning matter. Types of flares. There are two types of the flares. The first one is pyrotechnic decoy flares and the second one is pyropheric decoy flares. The pyrotechnic decoy flare produces a bright light or intense heat without an explosion. Pyrophoric flares work on the principle of ejecting a special pyrophoric material out of an airtight cartridge, usually using a gas generator. Now, we will see the ejection of flares. In ignition, the flares must be kept in an airtight storage compartment before deployment. These flares, known as pyrophoric flares, are made of special materials that ignite when they come in contact with the air. This is a safety and convenience factor since attempting to ignite a flare inside the fuselage and then deploying it is risky. External ignition method and accidentally puncture in the storage compartment would not result in a catastrophic fire on board aircraft as with the pyrophoric flares. In deployment, flares are most commonly gravity fed from a dispenser inside the aircraft's fuselage. Most currently used flares are of the pyrophoric variety, and then the dispensers do not have to ignite and deploy the flare at the same time. With pyrotechnic flares, a lanyard automatically pulls off a friction cap covering the exposed end of the flare as it falls from the dispenser. A friction surface inside the cap runs match head and striking and ignites the flares. In decoying, the flare burns at the thousands of degrees, which is much hotter than the exhaust of a jet engine. Iron missile seeks out of the hotter flame, believing it to be an aircraft. The modern decoy flares have their emission spectrum optimized to also match the radiation of the engines of exhaust of the aircraft. Now, the towed decoys. Decoy means a thing that intends to attract someone by deceiving them, and the term towed means to pull something behind one object. So basically, towed decoys are such that they are pulled along with the aircraft, and that decoy will be the part of the EW suits of aircraft. This countermeasure basically for the radar guided missile. Now, the capabilities of Towed decoys. Normally, EW suits cannot protect from missiles equipped with monopulse radar. These decoys are especially made for the SAM that can decoy and jam other radar along with especially this one. It can be used multiple times and also can be retracted. It can fly along with aircraft up to a speed of 1.6 Mach and can withstand and forces an acceleration of 9G. Due to this, it can also be easily used when the jet is cruising at supersonic speed. Is there any question?
Yes, is there any environmental effect from these decoys?
Yes, there is the effect from these decoys on environment. Once deployed, shaft fibers remain suspended in the atmosphere for a period of time, raising issues regarding air quality, safety from unintended interference with the FAA or other radar systems, risk to other aircraft engines. The time the shaft remains airborne depends on the combination of local meteorological conditions and the altitude of deployment. Issues associated with shaft deposited on land focus primarily on the chemical and physical impacts of shaft on soil functioning and human and wildlife health. The impact of shaft deposited on water depend in part on whether the water body is an ocean or an inland, island, or a running stream or river. Again, the primary areas of concern revolve around chemical and physical effects. Any other question?
How towed decoy will be benefit for aircrafts?
Yes. Suppose the aircraft is coming or approaching an area that is guarded by air defense. This towed decoy will help the aircraft to dodge the incoming missiles. Each and every Rafale of Indian has this decoy and it has one decoy under each wing. So whenever the Spectra EW suit of Rafale detects the incoming missiles, that is SAM or air-to-air, these decoys are released. These decoys will hear the incoming attacking SAM or AAM missiles away from the protected platform by creating an attractive false target signal. The missile will divert from homing the actual target, that is the parent aircraft. This decoy can be used against even sophisticated air defense like LY-80, HQ-9 and even S-400. etc. Due to this decoy's retractable nature, they can be also retracted back to aircraft after successfully evade jamming of the incoming threat. And after that, if another threat comes, it can be redeployed. We all know that missiles in the final stages has less energy. So if even PL-15 gets fired on Rafale from a distance of more than around 150 kilometers, then there are bright chances that the missiles will miss hitting the Rafales, as there are very high chances that the missiles could have deviated from the path by these decoys. Thank you.